Hey everybody, it's Mrs. C. It's been a while, boy. We have been far away from our screencasting, at least I can say I have. But I'm back and I am ready to rock and roll. So let's start. As you can see, I've got a coordinate plane. I'm just going to throw down a couple axes. There we go. You'll just have to wait for just 1 minute, watch the magic happen. Always make sure I've got arrows at the end of my axes. And let's get going. In class, what we've been working on is, quadratics in general. We've been trying to develop an intuition about quadratic behavior. And right now, I think we have gone from the form of y is equal to ax squared. That's the first form we worked on developing some intuition as to how these behave. And then we moved on, most of you have moved on to y is equal to ax squared. And then we add, that doesn't look like an a, ax squared. And then what was at the end? Do you remember? The second form plus c. Now, the final form that we're going to work on developing intuition, let's go into quadrant 3 over here, is y is equal to, put the first, ax squared, and the last plus c, and we're going to do a little middle guy. It's going to be plus bx. All right, that plus bx, that middle one, is going to give us the last of all the behaviors, I think. All, most. I'm sure there's always something else that they can do that we haven't talked about, but I think it'll cover just about everything. So I thought, some of you had said, oops, that's not an eraser. Some of you had said, could you, Mrs. C, could you just do a couple more examples for us so that we could, just hear your lovely voice at 5 o'clock in the morning? And I said, I would love nothing more than to do a couple pencasts on predicting quadratic behavior. So we've got to start with a quadratic. How about y is equal to, I don't know, negative 5, it's supposed to be a 5 halves x squared. So we start by predicting what this is going to look like. So let's just take a look at it. With the ones that look like this, meaning there is only a quadratic term, we can do two things. We can predict if it will be opening up or opening down. And the other thing we can predict is at what rate it will be opening up and opening down, meaning will it be wide or will it be narrow? And when we're talking about wide and narrow, that's subjective. So we're always talking about it with relation to, what is it? The parent function. That's right. Now the parent function is y is equal to 1x squared. So that's the one that we're always comparing it to. We ordinarily don't put the 1 in front of it because it's not necessary. So with regard to our predictions are always with regard to the parent function. It will be wider than the parent function. It will be more narrow than the parent function. It will be a reflection of the parent function over the x-axis, meaning it will be opening down instead of up. So in order to really talk about what we think this function of y is equal to negative 5 halves x squared is going to do, shouldn't we maybe, just for fun, one time, throw down the parent function, and then, we'll have something to compare it to. So when you talk about the parent function, we think about a table of values in our head, right? I do. I don't know about you. I think if x was equal to 0, say for example, if x was equal to 0, well, if x was equal to 0, 0 squared is 0, which means y would be equal to 0. And we've all realized that the major, I don't know what I just did, hold please, thank you. The major intuition is that when it's in this form, its vertex is on the origin, is at the origin. So we always can start with 0, 0, intuition. So there's one little thing we know. This baby, and as well as the parent function, starts at the origin with its vertex. So let me come back to here. Let me plug in a value of, say, 1. 1 squared is 1. So y is 1. Let me do 2. 2 squared is 4. Let me try 3. 3 squared is 9, and so on and so forth. So, shouldn't we throw down a couple negatives? I think we should. What about negative 1? If x was negative 1, negative 1 times negative 1 is? That's a good one. It's 1. And do again. Negative 2 times negative 2 is 4. So do you see this? No matter whether x is 1 or negative 1, the output is always 1. So if your x is 1 or if your x is negative 1, you'll get the same y value. And check it out. What about 2? No matter whether x is 2 or negative 2, the output will be 4 because a negative number squared is a positive, just like a positive number squared is positive. So that's nice to know because by finding 1, you already find the others. So let's plot a couple of these. Let's do 1, 1. Oh boy, this is probably not going to go too well, so I'm going to do something here. Hold, please. Hold, please. Let's see if this works better. That's a little better. How about 2, 4? 2, 4 there, and I know it's not perfect, but it's the best I can do with a stylus. How about 3, 9? 3, and then way up to 9. And can I squeeze another one? What would 4 be? I just really feel the need to make it all the way up. 4 would be, we'll go, 4 squared is 16. 4 times 4 is 16. Well, I go in intervals of 5, 5, 10, 5. I can just barely make it. Yes, I can't get that other point. It's in the middle of my menu. So there's my parent function. It doesn't look that great. See, mine don't look as very good either. So the question is this function, I'm going to rewind and play that back with a thinner font because that was pretty crazy. All right, let me try and do it better. It is really hard to sketch a graph with a stylus. Oh, come on, you can do it. There it goes. Oh, that's fun stuff. All right, there's my parent function. I'm just going to, I'm having way too much fun here. I'm just going to erase some of this. I don't want to erase my lines, so I'm just going to get close and leave some of that. I know it's going to bother many of you, but you're just going to have to suck it up. All right, we're predicting y is equal to a negative 5 halves x squared. So what you have to look at to decide whether it's right side up or upside down is something very simple. It's this little guy here, the sign of your a, or the sign of the coefficient of your squared term, and it's negative. If it's negative, it's going to be upside down. Now, I know it's going to be upside down, but I don't know the values of which it will be upside down. I don't know if it's going to be wide or if it's going to be narrow, but I actually do. If my value, and let me do another color here, if the value of the number, not the sign, just the number, we call it the absolute value of the a term, if it's greater than 1, then you are going to be skinnier, like this. If it's less than 1, if it's less than 1, you're going to be wider. Now, the farther away you are from 1, whether you're less or whether you're greater, will decide just how skinny and just how wide. So let's see, just how far away am I from 1? Well, what's 5 halves? I should have a little bit of intuition about this. 5 halves, is it bigger than 1 or is it smaller than 1? It's bigger than 1. 2 goes into 5, 2 whole times with 1/5 left over. It's 2 1/5, or 2.2. So bigger than 1. So we said if the number, just the blue that I circled, not the sign, the absolute value of the a term, that's why I didn't put a negative on this 5 halves. If the number's bigger than 1, I'm going to be skinnier. See, it's the opposite. Bigger than 1, skinnier. Less than 1, bigger than 1, skinnier. Less than 1, wider. So bigger, skinnier, less wide, those are opposites, if that helps you remember it. So I know I'm going to be skinnier. And so if I sketch my graph, I could just say, I don't know, it should be like something like that. Now that's awesome for the sketch of a graph, showing that you have the intuition of what this graph is going to be doing behavior-wise. But honestly, shouldn't we maybe throw down 1 or 2 points possibly that we know are on the graph, negative 5 halves x squared? Yeah, we should. Now, if I let you use a calculator, it would be super easy. You just type it into the Y window, and you would, you would just go ahead and copy the point. But I'm not going to let you do that. I want you to actually do some of the math. So let's come down here. It's not going to kill you. You'll be fine. Y is equal to negative 5 halves x squared, and pick a value for x. So here's my xy table. We know it's 0, 0. So let's pick another value of x. Let's do 2. I think 2 is a nice one because the denominator is a 2. So it's got to wind up having a factor of 2 in common here. 2 squared is 4. So I'm just going to erase that and put a 4. You're supposed to multiply these two together. You're supposed to multiply x squared to negative 5 halves. So I'm going to do it. 2 into 2, 1. 2 into 4, twice. Multiply numerator, numerator, denominator, denominator. In this case, they're all 1s, so we don't need them. Negative 5 times 2 is negative 10. Well, there you have it. I know that let me just show you what I do know. I've got to change my font so it's bigger again. Now, I know I have a point at the origin. I don't know if you can see that I'm putting it there, but I am. I know I'm at at positive 210. So you follow along, go over 2 and up to 10. You're there. Making it bigger. Okay. Now, because a graph in the form of ax squared is symmetrical to the origin, you know that you also have to have a point on the other side because they have to be symmetrical. So a little issue, not a big deal. Wow, I think I had done a really good job of guessing. I'm amazing. There's the graph. Now, I knew the other one. I knew the intuition. I didn't even do the math because I just knew I meant to change the font. Hold up. I knew over here that if I had squared a negative 2, I still would have had a 4. And so my x, y, would have been negative 2, still would have given me negative 10, which is what? No, negative 2. Oh my gosh. Oh no. What is happening? Oh, here's the big question. Do I leave this as a total screw up? Or do I abort and redo this entire video? I'm just going to hold here. Should I stay or should I go? You know what? I'm going to be brave. I'm going to go forward with this because I caught myself. I caught myself in my check step, and I'm proud of that. Here's what I did. I did the math. I said negative 2, negative 10. I plotted a point. I completely ignored it. That was supposed to be what? What does that say? It says it's 2, negative 10. Am I plotting 2, negative 10? No. Now, all of you out there who were confused have vindication. I screwed up. Oh my gosh. Which, I don't really mind that I screwed up for my students, but anybody that's out there, in Alaska or in Australia, you just have no idea what I just did to you. I'm so sorry. This is life. This is life in the math lane. You screw up, you hopefully catch it, and then you become one with your mistakes. It's okay. It's all good. If you catch it, it's all good. Don't you remember what our prediction was? Upside down. So my brain didn't even listen to the math that said that this point, let me put it right here, that point was supposed to be 2, negative 10, but I went up. 2, negative 10 is down here. And I know I can hear some of my students saying, I knew that. I knew that. I was so confused. Oh my gosh. I'm so sorry, babies. Okay, this. That's the graph. All right, clear the page. It's always a big question to somebody who does pen casts, I think. Do I leave a mistake or do I abort and just retake the whole thing? I'm leaving it, but I'm going to clear it up real quick. We said that the XY table, because I do have a lot of you that are saying, I thought I knew what I was doing, and then you went and screwed up, and now I'm all confused. That's all right. I am here to clear it all up. This is what we had said. 0, 0. We did the math. We said 2, negative 10. And at that point, I went and graphed it wrong because I was trying to compare it to the parent function and let the parent function confuse me. I should always look back at my prediction before I graph and remind myself that this one, negative 5 halves x squared, must be going down. And so before I graph, look at that and remember I'm going down. So now I'm going to do it the way I should have. I'm going to graph it knowing that I should be going down, going to 2, negative 10. And I know you're probably, some of you are thinking, well, of course it's going down. That says negative 10. That's easy to say, but you just don't always pay attention to the math. You got to always pay attention to the math. So here is not such a good sketch, but that is the graph that we have. And if you recall, I'm going to put the parent function back in. Parent function was at 1, 1. It was at 2, 4. It was at 3, 9. So it was going just a real loose interpretation, okay? Check step. Is my new function, my transform function, upside down? Yes. Is it thinner or more narrow than the original parent function? Yes, it is. So there is what catches us if we screw up. And this, my dear children, is the transformation that is the correct transformation. I'm going to go on. I'm going to do another one and try to redeem myself, start to finish, without screwing up. Let's predict the behavior of another graph. All right, let me give you the graph of y equals, oh, I don't know, how about, what to do, 3x squared. That's it, 3x squared. Gave you a nice one because it's kind of easy to do some of the math in your head. So let's start with the parent function, let's start with comparing it to the parent function. So I'm going to do this nice and big. Am I right side up or upside down? I am going to be up. Am I going to be wide or am I going to be skinny? I'm going to be skinny. So I am up and narrow. Can't miss that, right? Can't possibly not see that I'm supposed to be up and narrow. And by the way, usually I don't screw up on the up one. It's usually the down one that I have a problem with. So how did I know it was up? Because it's a positive a. And how did I know I was narrow? Because my 3 is greater than 1. And as long as I'm greater than 1, I'm going to be more narrow than the parent function. So let's do the math in our head. If I'm 0 in the x, I'm going to be 0 in the y. So I start with a point at the origin, not this point. Okay. Then what if I was 2? Well, 2 squared is 4, and 4 times 3 is what? It's 12. That's going to put me at 2, 12, right there. And then on the other side, right, negative 2, 12. It's about as one of the skinniest ones you can do, right? Whee! And there it is. Before I go, and I did take a look at my prediction, I am up and I am narrow. So I am looking good. All right, let's just clear these guys out. Let's try, try one more. Let's predict the behavior of, how about y is equal to a negative 1/4 x squared. All right, so I am upside down and I am narrow. So I am not narrow. I meant to say wide. Don't worry, I'm not gonna mess this one up. I am upside down because of this negative side, and I am wide because the value of 1/4 is less than 1. So I am looking at something that's going to be, I'm guessing, something that's going to look something like that. But let's get some values in and actually see if I sketched that properly. I'm going to throw in a different color just so that we can have some better points. So we know we're at 1, at 0, 0, at the origin. Now let's pick a value of a simple one. I'd like to go to 2 because I really don't want to graph a fraction. So if I do 2, if x is 2, let me change my font here for a second. If that was 2, then 2 squared is 4. And then it would be a negative 1/4 times 4, which would be a negative 1. So on my xy table, if I have x is equal to 1, I would wind up with a negative 1. So 1, negative 1, won't negative 1, 1. So it'll go like that, and that is 2. It almost appears not good. So I'm double checking. Yeah, because if I said 2. Okay, see how narrow? I just want to show you how you do these. If I eliminate all my mistakes, you lose some of my intuition. See that that's narrow? And do you see my purple line? I said wide. So I didn't want to do a 1 because I wanted the number to be a little bit bigger, which is why this value up here is not right. This was a 2. 2 was what rendered me the 1. So let me just take that away and erase this. Always be thinking when you're doing math. It's very easy, especially when you're talking and writing and thinking about all these different things, to make mistakes. So be really locked into what you're doing. So if x is equal to 2, y would be negative 1. That makes more sense to me because that's a little bit more in line with my original sketch. I mean, it's not perfect, but it's not going to send up the alarms for me that I screwed up anything up. I'm going to do another one. Let's pick 2, 3. 3 is good. So if this was 3, then 3 squared would be 9, which is going to change this to 9. Okay, and that's, don't freak out. It's okay. You get a fraction. This would be a negative 9/4, because this didn't cancel out, right? Let me just not completely confuse everybody. I've already done a good job with that. Negative 1/4 times 9 is going to be a negative 9/4. Negative 9/4, which you've got to be able to do in your head. That's 2 1/4. Now, I don't really want to graph that. That was great information, but it's not working for me. That's too much. I'm going to jump all the way to 4. So I want to see if the number 4 is going to give me a good piece of information that would be fun to graph. So let me try plugging in the value of 4. So 4 squared is 16. So 1/4 times 16. 4 into 4, 1. 4 into 16, 4. So that's going to give me a negative 4. So 4, negative 4. Okay. So 1, 2, 3, 4, negative 4 there. Come on. And then on the other side, because you're symmetrical, don't forget. Okay. Let me try one more. Let me try 8. See what 8 gives me. See, I'm picking numbers that have 4 as a factor, because then when I deal with that denominator, makes it a little bit easier for me. Now, I might have overshot my boundary here. That's a big jump. I want you to also see, if you do 8, 8 times 8 is 64. So now you're a negative 1/4 times 64. So when 4 goes into 64, it's not going to go in, I don't think, enough to make my number fit on my graph, but I'm going to try it. Okay, so that's going to give me a 4 into 4. Oh, I'm on eraser mode. La, 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 la. Get off of eraser mode. 4 into 4, 1. 4 into 64, 16 times. So this is going to give me negative 16. Alright, what can I fit there? So let's go over to 8. 8 and then down. Oh, way down, like down there-ish. So I get the feeling from my curve. I'm going to sketch it at, I am doing this, 8 down in that direction. Okay. Alright, now I want you to remember this isn't the best sketch. My original prediction is in purple. I said it was going to be wide. This doesn't look wide enough to me. Something looks wrong to me. So what I want to do is sketch the actual parent function. I know I have to be wider than the parent function. Do you remember? And I'm just going to flip my parent function over here just so we can see it. The parent function, if it was upside down, would be here. Let me make the font bigger. If the parent function was upside down, it would have a point here and here. Okay, and then it would be, remember, 2. That was 1 squared. So 2 squared is 4. But remember, I'm upside down. That's why, because I want to be able to really look at it. So it would be 2 and then 4. 2 and then 4, but really negatives. Let me do one more. 3 and 9. So 1, 2, 3, and then to 9. Okay, so am I doing that right? I think so. 3 and then 9. I'm happy with what I'm seeing, and I want to know if you know why I'm happy. Okay, that's the parent function, the purple. This purple line that I drew was my impression of what a wider graph. But when I kind of made a wider graph, I went a little too wide, didn't I? It's not really that wide. It's the green. So let's just make sure you understand the purple here that I have drawn would be the parent function if it was reflected. And it is what it is. It's we call it a neutral curve. The green is what the function y equals negative 1/4 x squared is. Now I have to look over here and see, did I predict it properly? Is it downward? Yes. Is it wider than the parent function? And since I did the parent function in purple, definitely you can see. So it makes sense, and now it doesn't look as bad. When I predicted, I just went a little bit crazy with my prediction. It would be really cool, though, to draw that back up later, maybe on a different video, and see exactly what would the A have had to be to make it that wide. Like, would it have been, what fraction would it have been? Would it have been 1/8? Maybe 1/16? I mean, how low do you got to go to be that wide? It was a pretty wide curve. So that's for another day, because my video is already approaching 30 minutes and I'm running out of things to say. Listen, guys, I hope my screw-ups have actually helped you. Usually they do. They make me look stupid, but that's okay. They only make me look stupid. We all know deep down inside the mistakes that we make, they don't define us. They actually are there to help us overcome and say, look at what I did. Let me not do that again. Let me learn from that mistake. So I'm not stupid, as I tell all my students to say, I can do this, and my mistakes are only going to make me better. So I hope my mistakes are going to help make you better. I hope this gives you a little bit more insight on the intuition of graphing a quadratic that is in the form of ax squared. The next video, we're going to put ax squared and ax squared plus c together, and we're going to do some more graphing and some more intuition on quadratic behavior. In the meantime, till I see you again, peace.